Good morning. On the last period we have seen Biat-Savart law. Then magnetic induction at any point due to long straight current carrying conductor and magnetic induction at center of current carrying circular arc of wire. Now today we have to see magnetic induction along axis. Magnetic induction, third one, magnetic induction along axis of current carrying circular coil. Today we have to see magnetic induction along axis of current carrying circular coil. Now see, consider a circular coil. Consider a circular coil. Consider a circular coil carrying current. Consider a circular coil carrying current I. Suppose this one as axis of coil. Suppose this one as axis of coil like this. Let P be any point along axis at which magnetic induction is to be determined. Let dl be the length of small element of coil. R, that is distance of point from center of coil. R, that is radius of coil, capital R, radius of coil. Theta, that is angle between length of coil with a line joining center of element to point P. Z, that is distance of point from center of coil along axis. See in diagram. We have to find magnetic induction along axis. See, consider a current carrying circular coil. Consider a current carrying circular coil. Let P be any point along axis of coil at which magnetic induction is to be determined. Let I, current flowing through coil, dl, length of small element of coil, theta, angle between element and line joining element and point. R, distance of point from center of element, capital R, that is radius of coil. I, current flowing through coil, dl, length of small element of coil, theta, angle between length of element and a line joining center of element to the point. Capital R, radius of coil. Then according to Biat-Savart law, magnetic induction at P due to small element, that is dB is equal to mu naught divided by 4 pi into I into dl into sin theta divided by r square. But length of element is perpendicular to line joining center of element to that point. Therefore theta is equal to 90 degree, which implies sin theta is equal to 1, and therefore magnetic induction becomes dB is equal to mu naught divided by 4 pi into I into dl divided by r square. Angle between length of element and line joining center of element to point P, this angle is 90 degree because they are perpendicular to each other. This is small magnetic induction due to small element. This magnetic induction is perpendicular to length of element as well as this line. This magnetic induction is perpendicular to line joining center of element to point P as well as length of element. Now see, the horizontal component of this magnetic induction, that is dB sin theta, vertical component dB cos theta. The horizontal component of this magnetic induction, are cancelled with each other. The horizontal component dB sin theta, the horizontal component of this magnetic induction cancelled with each other, and only vertical component dB cos theta adds with each other. And therefore this magnetic induction can be resolved into two components, that is dB sin theta, horizontal component, second one dB sin theta, dB cos theta, dB sin theta, horizontal component, and are cancelled with each other. dB sin theta, vertical component, adds with each other, and therefore magnetic induction, total magnetic induction becomes B is equal to integration of dB cos theta, dB cos theta. Here only vertical component present, which are adds with each other, and therefore total magnetic induction is like this. Put this value here, we get integration of mu naught divided by 4 pi into I into dl divided by r square into cos theta. From this diagram, cos theta is equal to cos adjacent divided by hypotenuse, that is capital R divided by small r, and r square is equal to z square plus r square. R square is equal to z square plus r square, and therefore this equation becomes constant term बाहेर काढा, constant term बाहेर काढा, we get mu naught divided by 4 pi हा तर ऑलरेडी कॉन्स्टंट आहे, करंट I पण कॉन्स्टंट आहे, राहिलं काय शिल्लक इंटिग्रेशन ऑफ cos theta r divided by small r into r square. ओके, राहिले इथे dl. Here which is nothing but mu naught I divided by 4 pi, here r divided by z square plus r square raised to 3 by 2 integration of dl. dl length of small element, dl length of small element, and total length, that is circumference, which is nothing but mu naught I divided by 4 pi into r divided by z square plus r square raised to 3 by 2 into 2 pi r. Pi ला pi cancel, 2 ने divide केले इथं आलं 2, and therefore magnetic induction along axis, that is mu naught I into r square, mu naught I r into r square divided by 2 into z square plus r square raised to 3 by 2. This is an expression for resultant magnetic induction along axis due to current carrying circular coil. आता आपण काय केलं, magnetic induction along axis of current carrying circular coil like this. Here suppose this one as a current carrying circular coil, let P be any point at distance z along axis at which magnetic induction is to be determined. I current flowing through coil, dl length of small element of coil, theta angle between line joining center of element to point P, r distance, capital R radius of coil, then according to Biat-Savart law. But length of element is perpendicular to length, therefore angle theta 90 sin theta 1. इथं आपण काय केलं, 1 ठेवलं, हे मिळालं. This magnetic induction is perpendicular to both R and dl, which can be resolved into two component, vertical component, horizontal component. Horizontal component are cancelled with each other and only vertical components adds with each other, and therefore total magnetic induction becomes dB cos theta. dB ची व्हॅल्यू इथे ठेवली, कॉन्स्टंट टर्म बाहेर काढतो, म्यू नॉट I divided by 4 pi इंटिग्रेशन ऑफ cos theta r by r, खालचा r स्क्वेअर तसाच, हा dl इथं, ह्या सर्व टर्म कॉन्स्टंट आहेत. जोपर्यंत आपण हा पॉइंट चेंज करत नाही तोपर्यंत ही आणि हे कॉन्स्टंट आहे. जरी समजा ही पोझिशन बदलली तर ह्या सर्व टर्म कॉन्स्टंट आहेत, त्याला बाहेर काढलं. dl that is length of small element, integration means total length that is circumference, जातील त्या टर्म घालवल्या. This is an expression for magnetic induction along axis of current carrying circular coil. One more concept or one more term. See, force between. यामध्ये आपल्याला आणखी एक टर्म पाहिजे आहे, ती म्हणजेच फोर्स बिटवीन टू लॉंग straight current carrying conductors. Force between two long straight parallel current carrying conductors. Now see, consider two long straight parallel current carrying conductors 1 and 2 separated by distance d from each other, carrying currents I1 and I2 respectively. Consider two long straight parallel current carrying conductors separated by distance d from each other. Let I1 and I2 are currents flowing through conductors. L, that is length of each conductor. L, that is length of each conductor. Then magnetic field at any point on second wire due to current in first wire. म्हणजेच या करंटमुळे या ठिकाणी निर्माण होणार मॅग्नेटिक फील्ड, मॅग्नेटिक इंडक्शन at any point, magnetic induction at any point on second conductor due to current in first conductor, that is P is equal to mu naught I1 divided by 2 pi t. हे झालं magnetic induction. This magnetic induction is perpendicular to plane directed inward according to Biat-Savart law. This magnetic induction is directed inward to the plane of paper, and hence force acting on second conductor, यावरती ऍक्ट होणारा फोर्स ऍक्टिंग ऑन सेकंड कंडक्टर ड्यू टू this magnetic field, that is force on second conductor due to magnetic field of first conductor, that is force, that is IPL. Current flowing through second conductor, that is I2, and therefore force becomes I2PL, which is equal to I2B, that is mu naught I1 divided by 2 पाय डी इंटू एल. बी ची व्हॅल्यू इथे ठेवली, विच इज नथिंग बट म्यू नॉट I1 I2 into L divided by 2 pi d. This is force acting on second conductor due to current in first conductor. This force, according to Lorentz force, L-O-R-E-N-T-J, Lorentz force, this force is directed towards first conductor. हित आपण काय केलं परत बघा. या कंडक्टर मधून करंट पास केला तर या कंडक्टरचं या ठिकाणचं मॅग्नेटिक फील्ड तयार केलं. हे मॅग्नेटिक फील्ड म्यू नॉट I1 डिवाइडेड बाय 2 पाय डी. आता हा कंडक्टर या मॅग्नेटिक फील्ड मध्ये आहे, हा कंडक्टर या मॅग्नेटिक फील्ड मध्ये आहे, म्हणून त्याच्यावरती ऍक्ट होणारा फोर्स आपण तयार केला. सिमिलरली फोर्स ऍक्टिंग ऑन फर्स्ट कंडक्टर ड्यू टू करंट इन सेकंड कंडक्टर. आता याच्यावरती ऍक्ट होणारा फोर्स, पहिला फोर्स या डायरेक्शनला, फोर्स on second conductor due to current in first conductor. Similarly, force on first conductor due to current in second conductor, F12 is equal to mu naught I1 I2 L divided by 2 pi d, and this force is directed towards second conductor F12. Thus, from this equation, these two forces are equal in magnitude but opposite in direction. Therefore, F21 is equal to minus F12. Means two parallel current carrying conductors carrying currents in same direction attracts with each other. म्हणजेच हा फोर्स या डायरेक्शनला तर हा फोर्स या डायरेक्शनला, मीन्स टू लॉंग स्ट्रेट current carrying conductors attracts with each other. If directions are same, then they attract with each other. This is force, and therefore force per unit length, that is force per unit length is equal to, फक्त ह्या लेंथला खाली या, म्यू नॉट I1 I2 divided by 2 pi d. This is force per unit length between two long straight parallel current carrying conductors. This is about magnetic field. आपण काय काय पाहिले या भागामध्ये, बायट-सॅवर्ट लॉ, त्यानंतर मॅग्नेटिक फील्ड at any point due to current carrying straight conductor, circular arc, axial magnetic field, and force between two long straight conductors. ओके, आणखी एक पॉइंट आपल्याला पाहायचा आहे, तो म्हणजे एम्पियर्स लॉ. AMPERS, एम्पियर्स लॉ. आणखी एक आपल्याला पॉइंट पाहायचा आहे, तो म्हणजेच एम्पियर्स लॉ. हा काय करू आपण नेक्स्ट पिरियडला पाहूया. ओके.